Now, today we will talking about asymptotes. Okay, so what is asymptotes? So asymptote is a tangent line on a curve. Okay, so first we will explain curve. What is curve? A curve is the locus of point whose position vector can be expressed as a function of single parameter. Okay, it means if a point moves in a plane, the figure is called curve. Suppose this is a point. This point moves in a plane. So this figure is curve. Okay, and you know what is straight line? So this is a straight line. Now, if this straight line intersect 2 points in a curve, this is secant. Okay, when Q tends to P, so in limiting case, PQ tends to tangent line. It means this is a tangent line for this curve. The concept of tangent on this curve is this is a tangent line. Okay, so if we suppose this is a line, okay, and this is a curve, but this curve is open, okay, and the line touches an infinite. So the concept of this tangent line is asymptote. Okay, this line is asymptote. Means this is not touched at finite distance. This may be touched at infinite. So the concept of this line means a line which touches at infinite is called asymptote. Okay, so now we will explain for firstly curve. Means we have definition of curve. So there are two type of curve. One is open curve and other is closed curve. You know, in school level, circle, ellipse, okay, these are closed curve. Okay, so each and every point we can draw a tangent line. Okay, each and every point we can draw a tangent line. Okay, now some curves which are open, so branch of these curves like parabola, hyperbola, so branches goes to infinite. So at that point, if we draw a tangent line, so the concept of that tangent line is known as asymptote. Okay, it means a line which is finite distance from origin and touch to curve at infinite. So this is called asymptote. Okay, so now there are three types of asymptote. One is horizontal, second is vertical, and oblique. Okay, so now this is horizontal. This is a curve and this is a tangent line which touches at infinite. So this is called horizontal. This is vertical. Okay, suppose this is a curve and this is a tangent line which touches to a curve at infinite. So this is called vertical. And this type of tangent is called oblique asymptotes. Okay, so there are three types of asymptote. One is horizontal, vertical, and oblique. Okay, so the concept of asymptote is this form. Okay, now what is the definition of asymptote? So a line which is finite distance from origin and touch to a curve at infinite, okay, is called asymptote to a curve. So as we know, the concept of asymptote for open curve. Okay, so a line which is finite distance from origin and touch to curve at infinite is called asymptote of a curve. ऐसी रेखा जो मूल बिंदु से निश्चित दूरी पर हो और वक्र को अनंत में स्पर्श करे, अनंत स्पर्शी कहलाती है. This is a curve y square 2a minus x is equal to x cube. Okay, and for this curve x is equal to 2a is an asymptote which is finite distance from origin, means this is 2a from origin and this touches to curve at infinite. Okay, asymptotes of algebraic curves. It means how we calculate asymptotes for any curve. So what is the process? So let us suppose this is a curve fxy is equal to 0. Okay, let us suppose y is equal to mx plus c, we an asymptote of 1. So what is the working rule? First we will put value of y in given equation 1. Okay, so we get an equation of the form f1 mcxn. Suppose this is equation of n degree, so by putting this value in 1, so we get a equation in form of m and c, because here we will eliminate y from 1 and 2, so we get f1 mcxn plus f of 2 mcxn minus 1 plus up to show on an is equal to 0. It means we will get an equation in form of m and c, and we will arrange equation in degree of x, means first highest degree x to the power n and then x to the power n minus 1 up to so on. So first step is we will put coefficient of highest degree of x, means coefficient of x to the power n equal to 0, means f1 m c equal to 0. And second step we will put f2 m c is equal to 0. Okay, so y f1 mc equal to 0, we get value of m, means m is equal to m1 m2 up to so on, and corresponding value of m y f2 mc equal to 0, we will get c. Okay, so corresponding values of m means for m1 we get c1, m2 we get c2 and so on. Okay, and then putting the value of m1 c1 m2 c2 in equation 2, it means we will get asymptotes y is equal to m1 x plus c1 m2 x plus c2 up to so on. Okay, so if every equation of curve of n degree, so we will get n asymptotes. Okay, so now this is an example to obtain the asymptote of a curve. So this is a given curve. Suppose this is equation number 1. So let y is equal to mx plus c is an asymptote. Okay, so first we will put y is equal to mx plus c in given equation 1. Okay, so now from 1 and 2, means substituting y is equal to mx plus c in given equation. So we get x cube plus 2x square mx plus c minus x mx plus c whole square minus 2 mx plus c whole cube plus x mx plus c minus mx plus c whole square plus 1 is equal to 0. Okay. So now our aim is to solve this equation. Okay. So here x cube plus 2mx cube plus 2cx square minus x m square x square plus c square plus 2mcx minus 2 m cube x cube plus c cube plus 3 m square x square c plus 3 mx c square. Okay, by the formula a plus b cube. Okay, so plus mx square plus cx minus m square x square plus c square plus 2mxc plus 1 equal to 0. Okay. Now we will arrange in powers of x. Okay. So we get x cube, coefficient of x cube is this thing, and then coefficient of x square, this thing, plus coefficient of x and then constant. Okay. So as we explain, what is the working rule? So we have explained means this is a curve and this is suppose asymptote. So first we will put y is equal to mx plus c in given curve. Okay. So we get this type of equation means f1 x to the power n plus f2 x to the power n minus 1 plus up to so on. Okay. So coefficient of x to the power n only contain m and c terms. Okay. Here m and c. Okay. And so first term is contain only m, not c. Second term contain m and c. Okay. So you see what is the working rule? First we will put f1 m is equal to 0. f1 not c, f1 m is equal to 0, and then f2 m c is equal to 0. So we get value of m and c. Okay. So first this is f1. Okay. And this is f2. So first we will put f1 m equal to 0. Okay. So by putting f1 m is equal to 0 and f2 m c equal to 0. Okay. So by f1 m is equal to 0, so now f1 m equal to 0, it means 1 plus 2m minus m square minus 2m cube equal to 0. So our aim is calculate the value of m. So this is a third degree equation in m. So this can also be written as 2m cube by multiplying by minus 1. So 2m cube plus m square minus 2m minus 1 equal to 0. By inspection method. Okay. So here constant is 1. So how many divisor of 1? So we will put either plus 1 or minus 1. This is the rule to obtain any equation. So here equation is third degree in m. So first we will try by putting 1. Okay. So if we put 1, so this is equal to 0. Means m is equal to 1 is a root of this equation. So you can divide by m is equal to 1. Or m minus 1, m minus 1, m minus 1. We will put some distance. So we arrange here 2m cube. So this is 2m square. 2m cube minus 2m square. But here plus m square. So plus 3m. So here 3m square minus 2m square, m square minus 3m, but we need minus 2m, so plus 1. Okay, now m minus 1 is common, so we will take m minus 1 common, so 2m square plus 3m plus 1 equal to 0. This is very easy. This is second degree, so we have here 3m, so 2m plus m, and product is 2. Okay, so now m minus 1 and 2m square plus 2m plus m plus 1 equal to 0. So here we will take common 2m, so here m plus 1 and here m plus 1, so this is very easy. 2m plus 1 and m plus 1 equal to 0. It means value of m is equal to 1 minus 1 by 2 minus 1. So now corresponding values of m from f to mc is equal to 0. Now f to mc equal to 0. What is the value of f to mc is equal to 0? So we will get f to mc. f to mc is nothing but 2c minus 2mc minus 6m square c plus m minus m square is equal to 0. So now I want to calculate value of c. So for m is equal to 1, here 2c minus 2c minus 6c plus 1 minus 1 is equal to 0. It means 2c cancel, 1 cancel, so c is equal to 0. For m is equal to minus 1, here 2c plus 2c minus 6c minus 1 is equal to 0. So 4c minus 6c minus 2 equal to 0. So here minus 2c minus 2 is equal to 0, means c is equal to minus 1. And by putting m is equal to minus half. Okay, so for m is equal to minus half, this is very easy to calculate. C is equal to also half. Okay, now putting the value of m and c in y equal to mx plus c. So for m is equal to 1, c is equal to 0. So first asymptote is y is equal to 1x plus 0. Second asymptote is y is equal to minus 1x minus 1. And third is y is equal to minus 1 by 2x plus 1 by 2. Okay, it means y is equal to x, y is equal to minus x minus 1, y is equal to minus x by 2 plus 1 by 2. So these are asymptotes of a given curve. So this is answer. Okay. Now another method or shortcut method to obtain asymptotes for a given curve. Okay, so suppose this is a curve, means y is equal to fx or fxy is equal to 0. This is a given curve. So what is the working rule? So first step is, first we will put x is equal to 1 and y is equal to m in highest degree term x is equal to 1 and y is equal to m in highest degree term of given curve. Okay, and we calculate phi n m. What is phi n m? In highest degree term of given curve by putting x is equal to 1 and y is equal to m. So this is called phi n m. Okay, and second step, we put phi n m is equal to 0. So this is equation in terms of x m. this is an equation in terms of m, and we calculate value of m, suppose m1, m2 up to so on. Next step is we will put x is equal to 1, y is equal to m in lower degree of highest degree. Okay, 1 lower degree of highest degree term, x is equal to 1 and y is equal to m, and we calculate phi n minus 1 m. Okay, and then the formula c is equal to, next step, minus phi n minus 1 m upon phi n dash m. What is phi n dash? Means this is phi n m. So differentiating with respect to m one times. So we calculate phi n dash m. So we will find the value of c by the formula c is equal to minus phi n minus 1 m upon phi n dash m. Okay. Next step is for different values of m, means m is equal to m1, m is equal to m2 up to so on. So we will calculate c, means c1, m1 c1, means for m is equal to m2 we get c2. So corresponding to value of m1, m2, m3, we will calculate c1, c2 up to c3, and then putting the value of m and c, means m1 and c1 in this equation mx plus c, means by putting y is equal to m1 and c1, so this is first asymptote, y is equal to m1x plus c1. By putting m2 and c2, so we get next asymptote m2x plus c2 and so on. Okay, so this is the method to obtain asymptote. Okay, so first remark is, if equation of curve fxy is of degree n, then total number of asymptote are n. Okay. Second remark is, if value of m are imaginary, then asymptotes does not exist. Okay. Parallel asymptotes. So it means if, so this is an important remark, that two parallel asymptotes. It means if phi n is equal to 0 gives two value m1 is equal to m2, means roots are equal. So in this case we will calculate the value of c by the following formula, means c square upon factorial 2 phi n double dash m plus c phi n minus 1 dash m plus phi n minus 2m is equal to 0. Okay, because when two roots are equal, then we calculate the value of c, so both value will be 0. So in this case we calculate the value of c by using this formula. Okay, so we calculate phi n minus 2. So how we calculate phi n minus 2? In similar fashion like we calculate phi n minus 1m. So in the highest degree term, so less than 2, in that term we will put x is equal to 1 and y is equal to m, so we get phi n minus 2. Okay, and we will put in this formula all the value, so calculate value of c. Okay, and then putting in the formula y is equal to mx plus c, value of m and c. Okay. So this is an example. Find the asymptotes of the following curve. Okay. So first we will check the highest degree term. There are x cube means highest degree term is 3. So how many term contains 3? So this is x cube, this is 3, this is 3 and this is 3. Okay. So first very carefully we will see highest degree terms and we calculate here n is equal to 3. Okay. So highest degree term we will put x is equal to 1 and y is equal to m. X is equal to 1 and y is equal to m. Okay. So here first we calculate phi 3m. Okay. So x is equal to 1. So 1 plus 2m minus m square minus 2m cube. Phi 3m is equal to 0. It means 1 plus 2m minus m square minus 2m cube is equal to 0. So this is very easy to obtain value of m. So m is equal to 1 minus 1 minus 1 by 2. Okay. Now what is second step? We will put x is equal to 1 and y is equal to m in second degree terms. So there are xy and y square. Okay. This is second degree term. So phi 2m. Phi 2m is equal to 3 1 into m. So 3m plus 3m square. Okay. Now we will calculate phi n dash m. Phi n dash m is nothing but phi 3 dash m. So what is phi 3 dash? 0 plus 2 minus 2m minus 6m square means minus 6m square minus 2m plus 2. We will calculate the value of c by the formula minus phi n minus 1 m upon phi n dash m. Okay. So this is minus phi 2m upon phi 3 dash m. Okay. So this is equal to what is phi 2? So phi 2m is 3m plus 3m square. So here minus 3m plus 3m square upon phi 3 dash m. So this is minus 6m square minus 2m plus 2. So this is equal to 3m square plus m upon minus plus 6m square plus 2m minus 2. Okay. So this is C. So we have for m is equal to 1, by putting m is equal to 1, c is equal to, so for m is equal to 1, c is equal to 1. Okay. M is equal to minus 1, c is equal to 0. Okay. And m is equal to minus 1 by 2, c is equal to 1 by 2. Okay. Now substituting the values of m and c in y is equal to mx plus c. Okay. So these are the asymptote. How many asymptote? 3 asymptote. So y minus x minus 1 is equal to 0, y plus x is equal to 0, and y plus x minus 1 is equal to 0. Okay. Now this is a next example. Okay. So first we see the given equation. So maximum power is 3. Okay. These are 3 degree terms, 1, 2 and 3. Y cube 2 1 3 1 2 3. Okay. So first we calculate phi 3m means x is equal to 1, y is equal to m. By substitute putting x is equal to 1 and y is equal to m in 3 degree term. So here m cube plus m plus 2m square. Okay. Now phi 3m equal to 0 means m cube plus 2m square plus m is equal to 0. This is very easy. M is common, so m square plus 2m plus 1 is equal to 0. So m is equal to 0 and m plus 1 square is equal to 0 and m is equal to minus 1 minus 1. Okay. Now, secondary term. So since phi 2m, so term which are contain second degree means secondary term are 0. So phi 2m is equal to 0.